Okay, logician. So this is 7D interactive truth table set number 1, problem number 4. So here's what we've got here. We've got a very complex compound sentence, but it's only got two simple statements that it's composed of, A and B. So we've got the standardized scheme of how we set up the truth table, the truth values of A and B over here, true, false, and true, true, false, false. And then they carry over those truth values underneath each occurrence of the simple statement. And then our job is to figure out two things. First of all, the truth values of that compound statement in each of these circumstances. And then, that's it. That's what we're trying to determine, the truth values. So I think one of the complicated questions to ask here is, where do I start? Like, which logical operator should I start with first? Now, my first rule for determining where to start is go as far inside the parentheses as you possibly can. So we've got two sets of parentheses. We can start with either set of parentheses. Let's start with this one. Now, we've got two logical connectives inside this parenthesis. Which one do we start with? Well, we've got to start with the negation because we can't figure out the horseshoe until we've done the negation. Now, why is that? Here's why. This horseshoe ranges over the entire not B, okay? It's like it's if A, then not B. Well, we don't know the truth value of not B until we figure out the truth values of this negation here. And then we can figure out the truth value of the conditional. So that's why we've got to start here. Now, determining the truth value of a tilde is pretty easy. It just reverses the truth value of whatever it ranges over. So if B is true, like in this first line here, then not B is going to be false. If B is false, then not B will be true. If B is true, not B is false. And it's true here. Now we can figure out the truth value of the horseshoe. Now, as I often say, the truth values of a horseshoe can be really confusing for people. And so here's how it goes. If the antecedent is true, but the consequent is false, then horseshoe is false, okay? That's the only condition under which horseshoe is false. Let me say one more thing. You might have been asking, which of these columns should I be paying attention to? Which one is really the truth value of the consequent of this horseshoe? Is it the B column or is it the tilde column? It's the tilde column. That's what you want to be paying attention to, because the consequent of this horseshoe, the then statement, is not just B, but it's not B. That's the truth value of not B. Okay. All right. So you got if true, then false. That makes the horseshoe false on line 1. On line 2, you got if true, then true. Horseshoe is true in that case. Now, on lines 3 and 4, the antecedent of the horseshoe of the conditional is false. If the antecedent of a horseshoe is false, then horseshoe is true. No matter whether the consequent is false or true, either way, horseshoe is not falsified. So therefore, horseshoe is true. Now, those two moves right there are probably confusing to you. Unless you've wrestled with this, you might be baffled. So let me tell you, if you don't get this, go back and study the truth table definition of the horseshoe from the textbook and from the PowerPoints. Okay. All right, now what should we do? Which truth value should we figure out? Well, again, let's go as far inside the horseshoe, inside the parentheses as we can. Well, here's the next set of parentheses, and we've got 3 different logical connectives. Which one do we start with? Well, again, we're going to start with the tildes. We can start with either one. We can't figure out the truth value of the wedge, the or, until we know the truth value of the 2 disjuncts. And the 2 disjuncts involve the tildes, so we got to figure out the tildes first. All right, so again, if B is true, like on line 1, then not B is false. True, false, true. And over here, same with the A. If A is true, not A is false. False, true, true. Okay, now let's figure out the wedge. And remember, which columns are we looking at? we're looking at the columns underneath the tildes. Why? Because this is a disjunction, an or statement. And what are the two disjuncts? It's either not A or not B. So you got to look at the truth values under the nots. That's why we do it that way. So the truth conditions for a wedge, for a disjunction, are that at least one of the disjuncts has to be true. If neither one of them are true, if they're both false, then the wedge is false. Okay, so here we've got false or false. That makes the wedge false. But here we've got, oh, there's a true. One of the disjuncts is true, so we're good. That's true. Here, this disjunct, the not A, is true, so true. And here they're both true, so that's true. Okay, now we are in a position to go outside the parentheses. So which should we do first, the dot or the negation? Again, we've got to do the negation first. Why is that? Because we're asking the question, are both these compound statements true, right? And we don't know the truth value of not all this junk until we determine the not. Like that's one of the conjunctions, all right? So we've got to figure this out first. Sorry, one of the conjuncts is what I meant. Okay, so again, it's a tilde. Now, what's it negating though? Which of the columns should we be reversing? Well, it's going to be the wedge. That's why, because the wedge ranges over everything inside of here. This tilde just ranges over A. This tilde just ranges over B. The wedge ranges over not A and not B. So that's what we're looking at, and that's what we're going to negate. So on line 1, if the wedge is false, then, the tilde is going to be true. And line 2, false, false, false. We're just reversing the truth values underneath the wedge. And now we can figure out the truth value of the dot, which is the main operator. How do we know it's the main operator? Well, that's the logical connective that ranges over everything else. It's saying that all this is true and all this is true. Now, so what are the two columns we're comparing? The column underneath the negation sign, which ranges over all this, and the horseshoe column, because that's the logical operator that ranges over everything else, A and not B. Okay, so those are the two we're looking at. Now, it's a dot, it's a conjunction. What are the truth conditions for a dot? Well, it's saying this is true and that's true. So both conjuncts have to be true. If either one of them is false, it's false. So we've got a false here. So this is false on line 1. On line 2, we're looking at, we got a false right here. We got a false on the next 3 lines. So it's false, false, false. And there we go. That's the truth table for this problem. It's false no matter what the truth conditions of A and B are, which is kind of interesting to know. It's actually, it's a contradiction. It can't possibly be true no matter what A and B refer to.